Welcome to Vidyasagar Academy. Analog and digital electronics experimental kits are manufactured here at Vidyasagar Academy. This is the video tutorial series with step-by-step experimental demonstration of all the kits that are provided to you. In this lecture, we will see Zener diode as line regulator. We suggest you to refer the experimental booklet that is provided to you.
In this experiment, we shall see Zener diode as voltage regulator. There are actually two types of Zener diode as voltage regulator. We can use this circuit, this same experimental board, for load regulation as well as line regulation. So first of all, we shall see line regulation first, because that is a simple experiment and you will understand the entire content and the circuit and schematic of this setup. So here are two voltmeters I am using. The first one is used here as AC voltmeter. This one is AC voltmeter, and I have put this voltmeter in 10 volt AC range. See, the dial here is quite distinct, and with that you can get the scale here 0, 2, 4, 6, 8 and 10. On this scale we have to record the readings. Similarly, I am using this voltmeter as a DC voltmeter, and in this DC voltmeter I have put this knob at DC volt 10 volt range. So in that way we are using two voltmeters. Now what we have to do is connect this AC voltmeter across this bridge rectifier, so that the AC voltage is coming up from this step down transformer will be measured by this AC voltmeter. And similarly, I am using this DC voltmeter. The range of this DC voltmeter, as I told you, is put in 10 volt DC range, and I am connecting this voltmeter across the output of this circuit. You should be very careful while connecting it. Red point to red probe and black point to black probe, so that the positive terminal will be connected to red probe and the negative terminal will be connected to the black terminal will be connected to negative terminal of this DC voltmeter. Now I shall switch on this experiment. The light indicator is showing here, and here we have got two different controls. These are simply the linear potentiometers. This is load resistance adjustment, and we have to put this load resistance maximum, and this is line voltage adjustment. We have used one very sophisticated type of dimmer circuit inside it, so that the transformer will receive the AC mains voltage by controlling this one. So first I increase the voltage of this one. You can see the voltage, AC voltage, is here right now just 1 volt. I have set the AC voltage coming up at the secondary of this transformer to be just 1 volt. So at the same time we have to note down the DC voltage reading. It is almost 1 volt. So we shall note down these values. 1 volt AC, and correspondingly we are getting 1 volt DC. First note down here that this Zener diode is of 5 volt, means the Zener voltage of this diode is 5 volt. The breakdown voltage of this Zener diode is just 5 volt. So as I go on increasing the AC voltage up to 5 volt, actually nothing will happen, and just after 5 volt the Zener diode will become go into breakdown, and therefore the output voltage should remain constant and it should not go beyond 5 volt. So that we shall see. I increase the AC voltage now to 2 volts say. You can see here also the linear output is obtaining. Here also the DC voltage is 2 volt. I increase it to 3 volt. The DC voltage is also similarly following the AC voltage. Then I go for 4 volt. Then also the output voltage, DC voltage, is again almost equal to 4 volt. Now I make it 5 volt. The output voltage is also 5 volt. Now there will be something magical going on. I increase this AC voltage to 6 volt. See, the Zener voltage remains constant, means the Zener diode is now operating in breakdown region, and therefore the Zener voltage, which is actually the output voltage across these 2 points, will remain constant and will not change at all. There is a slight difference in this needle over here because this Zener diode is not available in the market just for 5.0 volt. It is actually 5.1 volt. So we are getting a slight difference over here. It is 5.1 volt. So the Zener diode actually used in this circuit is 5.1 volt. So the voltage is now constant at 5 volt. If I increase this AC voltage further, there may be just a slight increase because the transformer used here is just 6 volt type of transformer. So you can see the AC voltage is 6 volt, but the output voltage has become constant. So in that way, up to 5 volt, we can plot the graph which should be quite linear, means AC voltage increases and corresponding DC voltage follows the magnitude of AC voltage. But as you go beyond 5 volt for AC voltage, then the output voltage remains constant. So in that way, we can plot the graph very easily just by using these readings. So with this, we come to the end of this experiment of Zener diode voltage regulator as line regulation.